doing. We're going to look at lesson 93 today, lesson 94 tomorrow, lesson 95 on Wednesday. We'll have our test on Thursday. So you will have, some of you will have one last chance to try to hopefully bring your grade up, as well as coming in and trying to maybe upgrade your test scores by working on them in lunch. But with only a couple days left, you have to come in here and do that on a separate sheet of paper, but then you have to make sure I have time to have you explain to me each one of your answers to get credit. That's the process, in case you don't know. You come in with a separate sheet of paper, you redo that question, and you do it thoroughly and completely so you can present it to me. I can understand what you're doing, follow every step of the way, and you can explain to me what you've done so I know that you know it, and then you get half credit for that question. Okay, so if there's 3 people in here and there's 2 people ahead of you and you're done, but they're explaining to me, a half-hour lunch can go by really quick. You can do the work but not get it checked. You may have to come in the next day or the day after that. So you got to allow yourself for a day or two to actually get in front of me, because everybody's kind of coming at the last minute. I had 2 people today that I was trying to get through, and one of them had to wait because the other person was taking up the time, and that's just the way it goes. So it's first come, first serve. So if you want to try to bring your grade up, that's one way you can do it, but you're running out of time for that. Amanda? Over what? Not right now. We got to do this lesson first, and if we have time, we'll go back. Was that practice that confusing for you, or not really? That was on percents, right? Percent, yeah. Percent of change. Okay. All right. Lesson 93. Um, these are two. Now we're doing two-step equations and inequalities. Okay. We're kind of muddying up the water a little bit because we're throwing a couple different things at you now. And we had these single step equations, which were, easier in comparison. When we had something like, looking at the board, it's not even turned on yet. Thought I turned it on, but I guess it didn't click. We're at crunch time, ladies. Just so you know, we're at crunch time. A lot of you need this last semester grade, this last quarter grade, to help out your second semester final. So if you didn't do particularly well this last 9 weeks, you need to come in here focused. You really, really do. Your academic line is at stake. Your life is at stake here. We have to get things moving for you in the right direction. So, if you took off the last 9 weeks and you didn't really try as hard as you could or whatever, you need to buckle down and make sure that you're staying focused on what's going on in class and keeping the distractions to non-existent. I'm not even going to say a minimum, because you can't afford to have any distractions whatsoever. Okay, so distractions are at 0. You have to force yourself to really sit tight, pay attention, and follow along. Because what we're talking about now, will be on the test on Friday, but you're also going to see it for the next quarter grade, that final grade you need. So this is important that you decide right now today, I'm going to make sure I understand every single thing that Dr. Kravchuk talks about. Julia? We're doing the test that comes out of the book, from the book. This actually won't be. It won't be, actually. That's a good point. Because we're going back to the old test way, the last 5 lessons will not be on the test, actually. So they're right. But these last lessons 91 through 95, will not be on this test. Okay, but they will be on the test that you're going to need for the new start, for this last push to summer. So let's look at this. We have 2x equals 30. This is one of the easier problems. We had 2x equals 30. This is lesson 93, today's lesson. Okay, and guys, instantly as soon as you see this, some things should be running through your head. Things like, okay, we're solving for x. I have to get x by itself. That's what you should be saying to yourself. Okay, these are the things you're trying to do. Listen, don't worry about the practice set anymore. Okay, the practice set is done. I'm not even looking at it. So stop doing it. Okay, I just wanted you doing that while I was getting this ready. So that means nothing to me. You're not grading for it. There's no completion. It's nothing. It was seat work to keep you occupied in math mode until I was ready to get this PowerPoint started today. So there's no sense in doing anything with it. You should need to be focusing on what we're talking about in this lesson right now. Okay, this is previous information. This is not new. As soon as you see this problem, ladies, 2x equals 30, you should instantly know that we're solving for x. That should be the first thing that you understand. We're solving for x. And the way we solve for x is we have to get x by itself. We know that we have a 2 on the side of x, so we have to get rid of it. And we get rid of it by dividing by 2. That allows us to make this a giant 1, or it cancels out and becomes x equals 30 over 2, because we know what we do on one side of an equation, right? What we do on one side of an equation, we have to do on the other side of the equation. So we divided by 2 on the left, we got to divide by 2 on the right. X then equals 15. Hopefully you can see 30 divided by 2 equals 15. And that would be our answer for that problem, 2x equals 30. And sure enough, when we have the problem 2x equals 30, if we replace 15 with x, that problem becomes 2 times 15 equals 30, and 30 equals 30. So this is an equation. There's an equality there. It's true. 30 equals 30, and that's what that is all about. So we're trying to find a value for x that will make that statement true, that 2x equals 30. So things are going to become a little bit clouded now, because now we're adding one more little hitch in the process. It's not a big deal if you make it a big deal, so don't be intimidated by this. It's really not that bad. We have 0.4x. Now instead of having equals 6, they're adding something else to this. They're giving us a plus 1.2. So we have to solve for x, right? We're trying to get x by itself. As a matter of fact, to make it a little more obvious, I guess I can make x red. Okay? We have 0.4x plus 1.2 equals 6. We got to find some number for x that will make the left side of this statement equal the right side, equal 6. So instantly when you see a problem like this, the first thing going through your head should be, I'm solving for x. I have to get x by itself. Okay, now, right now, the first thing we want to do before we do anything with the constant that is next to the x, we have to get rid of the number that is not involved with the x. We have this 1.2 over here, which happens to be a positive number. It's a 1.2. We have to get rid of this on this side before we can address the 0.4x. So if we have 1.2 that has a positive value on the left side, how do you suppose we get rid of the 1.2 on the left, Julia? We can subtract. So we can subtract 1.2 from this side. That gives us 0, right? So now I'm left with 0.4x plus 0 equals 6 plus a minus 1.2. What you do on the left side, you have to do on the right side. We subtracted 1.2 on the left, so you have to subtract 1.2 on the right. It's no different than if it was 2x equals 30. We divided both sides by 2. Now we're subtracting 1.2 from both sides. What you do to one side, you have to do to the other. So I'm going to rewrite this, because what we're going to wind up with is 0.4x equals 6. And then what I could do, instead of putting it up here, if that confuses you, I can just put down here minus 1.2, like this. Okay, and let me move this up a little bit. So now what I'm going to get is 0.4x equals, what is 6 minus 1.2? 4.8, positive 4.8. 4.8. Now this problem, it looks like the 2x equals, remember we had 2x equals 30 before? Now this kind of looks like that, doesn't it? We have just one number with the variable, an equal sign, and a constant. We have one number with the variable, an equal sign, and a constant. Okay, where before, you see we had this number here, a constant. We had a constant with a variable, an equal sign, and a constant. Now we're down to what we started with in our very first beginning when I was showing you the sample problem. We've made this complex problem into something that's a little bit easier because now we just have one thing on both sides that we have to take care of. Now, like any other time, we have a number next to the variable. We divide by that to get rid of the 0.4, right? So if we divide both sides by 0.4, because remember what you do to one side, you have to do to the other. This side is going to cancel out, right? 0.4 divided by 0.4 is 1, or x. And I'm going to have x equals 4.8 divided by 4. Or I can rewrite that as x equals 4.8 divided by 4. Remember, when I'm dividing and I have decimals, my decimal comes right up. It doesn't change its place. And now I do my math. 4 divided by 4 is 1. 4 times 1 is 4. Gives me a 0. I bring down my 8. 4 goes into 8 2 times. 4 times 2 is 8. I balanced out. I'm at 0, so I'm done. My answer is 1.2. X equals 1.2. Oh, my bad. Yep. Thank you. Absolutely right. Thanks for catching that. Good job. That was 0.4. Absolutely right. I forgot to put it over here. And you're exactly right. We would move it over one spot here. We'd move it over here. And we have to move our decimal up here, so it is 12. Nice catch, Amanda. Thank you. There you go. Beautiful. Christine? No. This is the way the book's showing it. That's how I'm teaching it today. Huh? I can't think of a different way to do this, honestly. And if you find a way that works, you need to test it to make sure it works with every problem, not just one or two. You know, it might just have a lucky way the numbers are going to line up. Okay, we're going to do another one. We're going to do another one. Okay, let's try this one and see if I can do it right this time. Okay, we have a minus 2/3. It's easy to make a mistake. That's why it's nice to have it written down. Because if what I would have done if I was doing this privately and having chances to think, I would have said to myself, wait a minute, 1.2 times 0.4 is not 4. I mean, I would have caught it. But if I didn't have it written down like I did every step along the way, I wouldn't know where I made the mistake. So that's why it's important. That's why it's very important to write down all of your work. Okay, so we have minus 2/3 x equals, or I'm sorry, here we go, another mistake already. Minus 1/2 equals 1/3. Okay? Listen, anytime we have a problem like this, ladies, where we have more than one number and we're trying to solve for x, we want to, whatever is by the x, we want to leave that alone and take care of the number that's by itself first. We want to get rid of the number by itself first. So in this situation where we have a minus 2/3 x minus 1/2, if we use algebraic addition, it's the opposite of 2/3 x plus the opposite of 1/2, which is negative 1/2. So this is a negative 1/2. This is a minus. You can say, was that a minus sign or is it a negative? If it's in front of the 1/2 like this, we're going to consider it a negative because it's the opposite of minus 1/2. Algebraic addition. So if I have a minus 1/2, how do I get rid of it on the left side? What do I have to do? I add a 1/2 on this side. Because now I have a minus 1/2 plus a 1/2 is going to give me a 0, right? So all this basically goes away. And what I'm left with is minus 2/3 x equals 1/3 plus 1/2. Okay? Remember what you do on the left side, you have to do on the right side. I added a 1/2 over here, so I have to add a 1/2 over here. Okay, so now my problem looks like this right here. Okay, this is how my problem looks. But I can't add fractions that don't have a common denominator. So I got to make a common denominator, and I know what number is common to 2 and 3. 6 is, right? And 2 goes into 6 3 times. 3 times 1 is 3. 3 goes into 6 twice. 2 times 1 is 2. Now I can add these together. Right? This becomes 5/6. So now watch. Hold on. Watch. So now we have minus 2/3 x equals 5/6. Now, like before, how do I get rid of the negative 2/3? I have a fraction. I don't divide, right? Liz, you have a question? I didn't add 1/2 to 1/2. I added, huh? It's 1/3 plus 1/2. Right up here? On the right side? Over here? Because I had a negative half. I have to get rid of this. If I have a negative 1/2, I have to get rid of the 1/2, so I add a half. That makes this 0. It goes away. I'm trying to get this by itself. If that was a 4, if that was a minus 4, I would have added 4. I have to get this to 0. This is a negative 1/2. So I have to add a half to get rid of it. Right? If I subtract another half, I'm going to wind up with what? What do I have if I have a 1/2 and a 1/2 and I subtract it? If I, yeah. Yeah, no. No. This is a minus 1/2 and we're adding 1/2, okay? That's why you got to use the algebraic addition and say the opposite of 2/3 x plus the opposite of 1/2. And we all know the opposite of 1/2 is negative 1/2. Yes, that's what we're trying to do. We're trying to get the variable by itself ultimately, but we have to get rid of this number that's not even next to the variable. We have to get rid of that one first. So I added a half to both sides to get rid of this negative 1/2. Because a negative 1/2 plus a positive 1/2 gives me a 0. That's what I want. Okay, so I'm left with negative 2/3. Let me scroll this back up. I'm left with negative 2/3 x equals 5x, or 5/6 rather, I'm sorry. And we have to get rid of that 2/3, a negative 2/3. How do we get rid of a fraction? No. Tanisha, you have a question? If you put parentheses around this like this, no, then you're multiplying negative 2/3 x times. If you put a positive sign there, you can add a parentheses if you wanted to. If you put a positive sign here, you would have to because you'd have two signs together, so you have to separate them somehow. Catherine? I'm saying if you use algebraic addition and you say this the right way, you will refer to this as a negative 1/2 because you're adding the opposite of 1/2. If you add the opposite of 1/2, you are adding a negative number because the opposite of 1/2 is negative 1/2. Okay, so that's the best thing I can tell you to do. That's the best thing I can tell you to do is use algebraic addition because it just makes your world a whole lot easier. It really, really does. Tanisha, does that answer your question? Okay. Okay, so when I do that, I am left with negative 2/3 x equals 5/6. And the way I get rid of a fraction is I multiply by its reciprocal. So the reciprocal of negative 2/3 is negative 3/2, right? Does that make sense to everybody? Okay, so I'm going to have negative 3/2 times a negative 2/3, and that's going to give me a negative times a negative is a positive. This all cancels out. So I'm left with x equals 5/6 times the reciprocal of negative 3/2, right? Or times the reciprocal, which is negative 3/2. Okay? And then when I could cross reduce this if I wanted to, but we're not going to for now. We're just going to do it at the end and see what happens. We have 5 times a negative 3, or a negative. Listen, we're actually taking this like this, and we can get rid of the multiplication sign, but this is a negative 3 halves. So we're not going to say 5 times a negative 3 or 6 times a positive 2. We're just saying that this fraction is negative, this fraction is positive. So what's our answer going to be when we have a negative times a positive? It's going to equal a negative. We're going to have a negative. 5 times 3 is 15. 6 times 2 is 12. We can reduce that down to what? To what? Yes, or 5/4, right? If you multiply it by 3, this is going to be 5, this is going to be 4, and it's negative. Negative 5/4. X equals negative 5/4. Okay? Everybody understand that? Anybody confused big time? On a scale? Okay. On okay or on confused? On good, okay. Okay, let's see if we can do one more. Okay, let me stop this here and make a new one.